All right, welcome to The Explainer. So if you're prepping for a system design interview, chances are you've thought about using LLMs for classification. But how do you actually go beyond the buzzwords? In this explainer, we're going to give you a real, practical framework to help you confidently nail this common but pretty tricky design challenge. So, first up, we're going to demystify how a model that's built to generate text can somehow be used to classify it. Then, we'll crack open the toolkit and compare prompting versus fine-tuning. From there, we'll put on our architect hats and actually design the whole system. And finally, we'll get into the weeds, the real-world challenges of keeping it all running smoothly in production. Okay, let's just tackle the big question right out of the gate. How on earth can a model that's designed to write poetry or code be used for a really strict classification task? It sounds a little weird, right? So let's really break down how this magic actually happens. And this is really the core question, isn't it? On one side, you've got this creative, free-flowing, generative power of an LLM, and on the other, you have the rigid, box-checking nature of a classifier. So how do you get one to do the job of the other? Well, the secret is all about how you frame the problem. Okay, so think about it like this with a simple analogy. Imagine the LLM is an incredibly smart librarian. You wouldn't try to train this librarian from scratch to categorize books. That'd be crazy. Instead, you just give them a really clear instruction, like, hey, read this summary and just tell me if it's fiction, nonfiction, or a biography. The LLM, just like that librarian, uses its gigantic pool of existing knowledge to follow your command, and it just generates the right category as its answer. So we know it's possible. Great. Now let's get into the how. When you're actually building an LLM classifier, you've really got two main tools in your toolkit, prompting and tuning. And honestly, understanding the trade-offs between them is absolutely key. Okay, this right here, this is the fundamental trade-off you absolutely need to nail for your interview. Prompting is your best friend when you need flexibility. When your labels are still changing or you just need to iterate really, really fast, it's perfect. Fine-tuning, on the other hand, that's your powerhouse for when things are stable and you need to scale up. It's going to give you much better throughput, lower latency, and more consistent results. But you do give up some of that initial flexibility. So let's zoom in on prompting for a second, because there are two main ways to do it. With zero shot, it's simple. You just give the model instructions. But with few shot, you give it instructions plus a few really good examples. You can almost think of those examples as a tiny little training set you give it right in the moment. They help guide the model on all the subtle details, the edge cases, and even the exact output format you want, which is just incredibly powerful for complex tasks. All right, so we've got our tools. Now it's time to pull back and think like a real system architect. Because remember, in a system design interview, you're not just talking about a model, you're designing an entire, robust, reliable system. Now this is so important, and honestly, it gets overlooked all the time. You could have the smartest model on the planet, but it's totally useless if your labels are a mess. That's why you have to treat your labels like a core product feature. That means you need clear, non-overlapping boundaries, explicit rules for what's in and what's out, and a curated set of perfect examples. And the golden rule? It's super simple. If a human expert can't apply your labels consistently, your LLM has no chance. Class imbalance, the classic machine learning villain, right? And guess what? LLMs are not immune. The model is always going to be biased towards the class it sees the most. So your job, as the architect, is to fight back strategically. You can do that at the input level by feeding it more and better examples of those rare cases. You can do it at the evaluation level by building special test sets. And you can do it at the system level with things like human review policies that understand the business cost of getting it wrong. Okay, let's talk about metrics. Because accuracy, it can be a total trap, dangerously misleading. In the real world, you have to connect your metrics to actual business impact. So let's say you're building a fraud detection system. A missed case, a false negative, could be a disaster, so you're going to optimize for recall. Or maybe you're filtering spam. A super important email getting flagged, a false positive, that's a huge problem, so you're going to focus on precision. Things like the F1 score and confusion matrices, these are the tools that let you have that nuanced, business-focused conversation. All right, we're heading into the home stretch, and honestly, this might be the most important part. Let's talk about what it really takes to go from a cool demo to a production-ready system that can actually survive the chaos of the real world. Because once you're in production, a whole new world of problems opens up. You've got label drift, that's when the meaning of your categories slowly changes over time and your model has no idea. You've got prompt brittleness, where one tiny change to your prompt makes performance just tank. And you will constantly be fighting formatting errors, and my favorite, the model being 100% confident while being 100% wrong on some tricky input. This is exactly why relying on a single accuracy number is just a recipe for disaster. This quote right here is everything. This is how you elevate your answer from just okay to senior level. So instead of getting bogged down talking about 99% accuracy, you shift the conversation to operational resilience. You start asking questions like, okay, what level of ambiguity can the product actually tolerate? Or what's our government's process for updating the label taxonomy? This shows you're not just thinking about the model, you're thinking about the whole system and where it fits in the business. And look, having a human in the loop, that's not a sign of failure. Not at all. It's actually a super smart design pattern for managing risk. Any high-stakes decision, we're talking legal, medical, financial stuff, should probably get routed to a human. Same thing for really ambiguous cases or when the model spits out a low-confidence score. Human review is your strategic safety net, making sure you're accurate where it matters most. Which brings us to the final, and maybe the most crucial question of all. Because look, being a great engineer isn't just about knowing how to use the shiniest new toy. It's about knowing when a simpler, older tool is actually the better choice. So before you immediately reach for that LLM, you have to ask yourself, is this a stable, high-volume task? Do I really need all the complexity of a generative model? Sometimes a classic fine-tuned classifier is still the right answer. And being able to justify that choice with a rock-solid understanding of the trade-offs, that's what will truly set you apart.